Hello, students. So we have spent the last several lessons looking at various aspects of polynomials and rules of exponents and things like that. Our eventual goal with polynomials is going to be to solve equations that contain polynomials. So our goal is going to be to solve, eventually, something like x squared minus 3x plus 2 equals 0. However, we don't yet have the tools to solve something like this. Basically, we're not ready. You can take plenty of time if you want to pause the video and try and solve this using the methods that we've learned before. But the problem is that we have an x squared term and an x term, and they're not like terms, so we can't combine them. So we're going to be stuck with two different x terms no matter what we do, at least as far as the rules that we already know, with the tools that we already have. You're not going to be able to get x alone on one side and solve it like x equals 3 or x equals 12 because of these two terms that can't be combined. So we need another tool, and that tool is going to end up being factoring. We need to learn factoring. All right. Now, we have factored numbers before, right? If we wanted to factor 6, we could write it as 2 times 3. Factoring a number meant writing it as a multiplication. And the same thing is true when we are factoring a polynomial. Factoring a polynomial means writing it as a product of 2 or more polynomials. Now, we saw that when we were multiplying polynomials, there were several different methods that we used depending on the number of terms in the polynomials. And with factoring, we're going to see something similar. Over the next 5 or 6 lessons, we're going to learn several different methods for factoring, and we're going to get practice, and we're going to look at a strategy, an overall strategy for factoring, and then eventually we're going to circle back to solving equations with polynomials in them. But unfortunately, it's going to take us about a week and a half or even 2 weeks to get back to solving this goal. We've got a lot of work to do, but we're going to look at these factoring methods one at a time so that we can get good at each method individually. And today we're going to focus on factoring out the GCF. Now, before we get into a factoring problem, I want to do a multiplication problem because this is going to actually help us with the factoring. So let's take a look at 3x squared times x cubed minus 5x plus 2. And let's perform this multiplication. How can we multiply these? Well, because the first one's a monomial, we can use the distributive property. When we distribute, 3x squared times x cubed is 3x to the 5th. Then we have minus 3x squared times 5x is 15x cubed. And then plus 3x squared times 2 gives us 6x squared. What we have just done is multiply. The reverse of this is actually factoring. If we want to start with one polynomial and write it as a product of 2 or more polynomials, that's factoring. So what we're really trying to do is go backwards. We're trying to undo this multiplication. So somehow we need to go from this polynomial and figure out that there's a 3x squared that can go out front and that we have x cubed minus 5x plus 2 on the inside. And I'm going to show you exactly how we figure out that it's the 3x squared that goes out front. What we're going to do, this is going to seem weird at first, but after we do the first example and we get to more examples, it's going to seem absolutely normal. I want to take the three terms in our polynomial, 3x to the fifth, negative 15x cubed, and 6x squared, and I want to factor each of these individually. Okay? Now we know that 3 is a prime number, doesn't factor, so we're going to leave the 3 there. And then x to the fifth is x times x times x times x times x. I'm going to expand that out. In the next one, we've got a negative out front. 15 is 3 times 5, and then x cubed is x times x times x. And then in that last term, 6 is 2 times 3, and x squared is x times x. So I've just factored each of these individual terms. I've expanded the x's, and I factored the coefficients. And what I want to ask you is, what do all three of these have in common? Well, if you look, all of them have a factor of 3 in common, and all of them have at least 2 factors of x in common. So if we're talking about what they have in common, they've got a 3, an x, and an x in common, and 3 times x is 3x squared, which is exactly what we find out front. So this thing that goes out front, the 3x squared, is actually the greatest common factor, or GCF, of these different terms. It's the thing that's the biggest they all have in common. Now remember, we also have this other part, the x cubed, the negative 5x, and the positive 2 in the parentheses. Where do those come from? Well, if we look at what's left over, x times x times x is x cubed. And then 5 times x with a negative is minus 5x. And then this 2 over here is the last term. And so the GCF, the thing that they have in common, is what goes out front. And then what goes in the parentheses are the leftovers, the bits that aren't included in the GCF in each of those. And this is actually how we pull out the GCF. We factor out the GCF. We're going to do one more example here, and then I'm going to ask you to click on the link below and watch some of the other examples so that you can get really good practice here. Let's factor out the GCF from 24x squared y squared plus 8xy cubed. We're going to do just what we did in that last problem. We're going to take each of the terms individually, and we're going to factor them one at a time. 8xy cubed. Let's see. We need to factor 24, and that's a rather complicated one, so I'm going to build a factor tree. 24 we know is 4 times 6. 4 is 2 times 2. 6 is 2 times 3. So 24 is 2 times 2 times 2 times 3. And then x squared is x times x. Y squared is y times y. So we're good there. Now let's take a look at 8xy cubed. 8 is 2 times 2 times 2. And then we have times x times y times y times y. Now we need to figure out the greatest common factor, what they have in common. They've got 3 factors of 2 in common. They've got an x in common, and they've got 2 factors of y in common. So the GCF is going to be 2 times 2 times 2, which is 8, and then x, and then y squared. And then in parentheses, we're going to need the leftovers. If you look at the leftovers from the first one, we've got 3x. So the first leftover is going to be 3x. And then plus, if we look at the leftover in the second one, we just have a y there. So we've got 3x plus y as our leftovers. And this is our factored form. If you want to check that you've factored something correctly, you can use the distributive property to multiply it out and make sure that you get what you started with. Now, really quick, I want to redo this problem, but I want to try it out mentally without writing everything out. 24x squared y squared plus 8xy cubed. Because we want to get to the point where we don't have to write all of this out and use highlighters to figure out the GCF and the leftovers and all of that. So let's take a look at these two terms. And I'm just going to ask you, without writing anything down, what do they have in common? If you look at 24 and 8, both of those are divisible by 8. So we know that the GCF will contain an 8. If we look at the x's, we've got x squared and x. Well, both of those contain 1x. And then if we look at the y's, we've got y squared and y cubed. Both of those contain a y squared. So we can get the GCF just by looking at the terms and comparing them and trying to figure out what the biggest factors are that's contained in them. And then once we do that, to figure out the leftovers, we can ask ourselves, what happens when we take these terms and pull out the GCF? 24 divided by 8 is 3. X squared, we pull out an x, or we divide by an x, it leaves us with an x. And then y squared divided by y squared is just 1. So all we're left with there is 3x. And then in the other one, 8 divided by 8 is 1. X divided by x is 1. Y cubed divided by y squared, that leaves us just with 1y left. And we get the same answer, but we did it without having to write out those factorizations. Now, you might need to write out the factorizations for the first few example problems as you're getting used to it, but I want you to do more and more of them mentally as you get comfortable with this, because identifying greatest common factors is going to want to be something that we're doing just out of habit without too much work, instead of something that takes us 10 minutes to go and factor everything and pull it out and whatnot. So we want to get really good at this.